your AI agent just connected to your production database. It can read everything: table sizes, slow queries, index health, row counts. And it cannot write a single byte. That is not a restriction someone forgot to lift. That is the entire design. Pglens is an open-source project that gives AI agents 27 read-only PostgreSQL tools through something called MCP, the Model Context Protocol. If you have not heard of MCP yet, think of it as a standardized way for AI models to call external tools. Instead of writing custom database wrappers every time you want your agent to understand your schema, Pglens ships those tools pre-built and ready to connect. So what does that actually look like in practice? You point Pglens at a PostgreSQL connection string. It registers 27 tools with your MCP-compatible AI client, things like listing all tables and their sizes, fetching index usage statistics, running explain on a query to see its execution plan, checking for table bloat, identifying unused indexes, pulling constraint definitions, reading column statistics. Your agent can now reason about your database the same way a senior DBA would, by looking at the data that describes the data. I ran it against a test database with a few hundred tables and some intentionally bad indexes. I asked the agent a plain English question: which tables are missing indexes on their foreign keys? It called 3 tools in sequence, cross-referenced the results, and gave me a list in about 4 seconds. That would have taken me 10 minutes of manual querying to reproduce. But here is the thing: Pglens does not execute your queries for you. It exposes metadata and diagnostic tools, not a raw SQL execution engine. You cannot ask it to run an arbitrary select and get rows back. That boundary is intentional. The project is not trying to be a general-purpose database client. It is trying to be a safe inspection layer. What surprised me was how disciplined the scope is. Every single one of the 27 tools is read-only. There is no tool for insert, update, delete, or drop. There is no escape hatch. If your agent goes off script and tries to modify data, Pglens simply does not have that capability. For teams who want to give an AI agent access to production infrastructure without a security review that takes 3 weeks, that constraint is actually a feature. Now, what does it not do? It does not give you query history unless that is already stored in your database via pg_stat_ statements or similar extensions. It does not monitor in real time, it takes a snapshot when called, not a continuous stream. And it does not understand your application logic. It can tell you that a table has 40 million rows and no index on a timestamp column. It cannot tell you whether that matters for your specific workload. That context still has to come from you. It also does not handle authentication complexity out of the box. You pass a connection string, and that string carries whatever permissions it carries. If you accidentally give it a super user connection, the read-only guarantee from Pglens still holds, but you are still exposing more metadata than you probably want. Role scoping is your responsibility. Looking ahead, the realistic next step for something like this is tighter integration with AI coding assistance. Imagine your IDE agent automatically pulling schema context before it writes a migration. Or a CI pipeline that lets an agent audit index coverage before a deploy. Those use cases are not hypothetical, they are one MCP configuration file away from being real, once tools like Pglens become stable enough to trust in automated pipelines. If you are deploying this kind of agent infrastructure at scale, DigitalOcean's managed databases pair cleanly with a setup like this: you get a connection string, you point Pglens at it, and you are running. So why does Pglens exist? Because the alternative is chaos. Right now, if you want an AI agent to understand your database, you either write custom tool wrappers from scratch, which takes days and breaks every time your schema changes, or you give the agent direct database access with no guardrails. Both options have failed in production for real teams. Pglens is the answer to a question that every engineering team with an AI agent will eventually ask: how do I let the model see the database without letting it touch the database? The 27 tool count is not arbitrary either. It maps to the actual diagnostic surface area a DBA uses when they are investigating a performance problem or reviewing a new schema. It is not trying to be everything. It is trying to be exactly enough. If you are building agents that work with data infrastructure, this is one of the most practically scoped tools I have seen. Not the flashiest project. but the kind of thing that quietly ends up in a lot of production stacks. Next episode, we are looking at another MCP based project, this one for file systems, and the safety story gets a lot more complicated. Subscribe so you do not miss it.